am Siti Marsara binti Rizam 20109218 from Group 3. I would like to present about introduction and breakdown of hydropower generation. So, let's start. Hydroelectric power, from the Greek word hydro, which means moving water, is a form of energy derived from the force of a moving water. This kinetic energy is converted to mechanical energy by turning the blade of water turbine. The turbine shaft drives a generator which transforms mechanical energy to electrical energy. This process is known as hydroelectric power or hydropower because water is the primary source of electrical energy. This figure shows how water is constantly moving through the hydrologic cycle, which is powered by solar energy. Atmospheric water reaches the Earth's surface as precipitation in the hydrologic cycle. Some of water evaporates, but the majority of it percolates into the soil or runoff as a surface runoff. When water and melting snow eventually reach a ponds, lake, reservoir, and ocean, where evaporation occurs on a regular basis, the hydrologic cycle ensures that the water is a renewable resource. There are three types of hydropower facilities, which is impounded, diffusion, and pumped storage. Now, we go to history and background of hydropower generation. Hydropower has been used for centuries. The Greeks used water wheel to gain wind into flow more than 2,000 years ago. In the early 18th, American and European factories used the water wheel to power machine. In 1849, British-American engineer James Francis developed the first modern water turbine, the Francis turbine, which remains the most widely used water turbine in the world today. In the 1870s, American inventor Liston Allen Patton developed the Patton wheel, an impulse of water turbine, which he did innovation in 1880. In the late 19th century, the force of falling water was used to generate electricity. The first hydroelectric power plant was built at Niagara Falls in 1879. In the following decades, many more hydroelectric plants were built. At its height in the early 1940s, hydropower provided 33% of this country's electricity. The 20th century witnessed rapid innovations and change in hydropower facility design. Not long after the turn of the 21st century, hydropower development gained a renewed momentum, particularly across Asia and South America. Between 2000 and 2070, nearly 500 gigawatts in hydropower installed capacity was added worldwide, representing an increase of 65% with growth since 2010, already outstripping that recorded in the first decade of the century. In Malaysia, they have 20 plants of hydropower generation. The majority of Malaysia's energy generation capacity is coal and natural gas fired, but the government is working to attain a more balanced portfolio of electricity generation in the future years in order to satisfy growing demand and reduce reliance on fossil fuels. This has benefited Malaysia's hydropower sector, which had previously been centered primarily in Peninsular Malaysia. But because to its high rainfall and geographic location, the state of Sarawak on the island of Borneo is projected to see the majority of new development. For example of hydropower plants in Malaysia is Ulu Jerai Hydroelectric Power Plant in Pahang and Bakun Hydroelectric Power Plant in Sarawak.
Hi, my name is Nordini Atira binti Gazanta. My metric number 2010921175.
Today I want to present about theory that how the hydropower is worked. This concept was discovered by Michael Faraday in 1831 when he found that electricity could be generated by rotating magnets within copper coil. When the water has completed its task, it flows on unchanged to serve other needs. Hydropower is generated. Some power plants are located on rivers, streams, and canals, but for a reliable water supply, dams are needed. To generate electricity, water must be in motion. This is kinetic energy that means moving. When flowing water turns blades in a turbine, the form is changed to mechanical energy. The turbine turns the generator rotor, which then converts this mechanical energy into another energy form. Since water is the initial source of energy, we call this hydroelectric power. Dams store water for later release for such purposes as irrigation, domestic and industrial use, and power generation. The reservoir acts much like a battery, storing water to be released as needed to generate power. The dam creates a head or height from which water flows. A pipe, which is penstock, carries the water from the reservoir to the turbine. The fast-moving water pushes the turbine blades, something like a pinwheel in the wind. The water falls on the turbine blades, then the rotor, the moving part of the electric generator. When coils of wire on the rotor sweep past the generator's stationary coil, which is stator, electricity is produced. After that, once the electricity is produced, it must be delivered to where it is needed, which is our homes, schools, offices, factories, and others. Dams are often in remote locations and power must be transmitted over some distance to its users. Vast networks of transmission lines and facilities are used to bring electricity to us in a form we can use. All the electricity made a power plant comes first through transformers, which raise the voltage so it can travel long distance through power lines. Voltage is the pressure that forces an electric current through a wire. At local substation, transformer reduce the voltage so electricity can be divided up and directed throughout an area. Transformers on poles further reduce the electric power to the right voltage for appliances and use in the home. Then we go to turbine. While there are only two basic types of turbine, impulse and reaction, there are many variations. The specific type of turbine to be used in a power plant is not selected until all operational studies and cost estimates are complete. The turbine selected depends largely on the site conditions. First, we talk about a reaction turbine. A reaction turbine is a horizontal or vertical wheel that operates with the wheel completely submerged, a feature which reduces turbulence. In theory, the reaction turbine works like a rotating lawn sprinkler where water at a central point is under pressure and escapes from the ends of the blades, that's causing rotation. Reaction turbines are the type most widely used. Second is an impulse turbine. Impulse turbine is a horizontal or vertical wheel that uses the kinetic energy of water striking its buckets or blades to cause rotation. The wheel is covered by a housing and the buckets or blades are shaped so they turn the flow of water about 170 degrees inside the housing. After turning the blades or buckets, the water falls to the bottom of the wheel housing and flows out. That's all from me. Thank you.
I'm Nurfahani Chowdhury. I will explain about the mathematical model of hydropower. Hydropower plant utilize the condenser energy content in boiling water and convert it to electricity using protodynamic heat movement. Applying Bernoulli's equation to reference point 1 and 2 up and down of the hydroelectric power plant. Intake structure. Applying Bernoulli's equation between 1 and 2. In Vesta, applying Bernoulli's equation between 2 and 3. In the turbine, pressure energy is converted into mechanical energy as the fluid passes from 3 to 4. Conversion losses are described by the efficiency of the turbine. In the theories, applying Bernoulli's equation between station 4 to 5. And the last, complete system. Applying Bernoulli's between station 1 to 5.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Syafiqah binti Muhammad Kamal. My metric number is 201092177. Today, I would like to present about hydropower generation. First of all, let us take a look on a video about hydropower generation in Slim River, Perak. This video is taken during my internship in diploma. In this video, we can see that there are two turbines that have been installed in this hydropower station. In Malaysia, there are several hydropower stations such as Muru Hydropower Station in Sarawak. This hydropower station consists of four 236 megawatt turbines. The average power produced is 635 megawatt and being delivered to power grid for the consumer. Next, the largest hydropower station in Malaysia is Bakun Hydropower Station, which located also in Sarawak. This plant consists of 830 megawatt turbines and directly connected to Sarawak existing power grid. The average generating power from this hydropower station is among 1,700 megawatt to 2,110 megawatt. In Peninsula Malaysia, there are Pergau Hydropower Station, which located in Kelantan. This plant was located underground and operate at daily load factor around 25%. This plant was powered by four 150 megawatt turbines. Next, Malaysia also has Bintang Hydropower Station in Perak. This plant was designed as the upper part of two power stations. The outflow from the river is transferred to a lower power station via a direct penstock. This hydropower station was connected to TNB grid and entered commercial at full capacity. Next, let us take a look on a percentage of energy mix. Energy mix is the combinations of various primary energy sources such as oil, natural gas, coal, and renewable energy. As we can see in this pie chart, the data collected in 2018 shows that the natural gas is the highest percentage of energy mix in Malaysia. In Malaysia, there are some programs and companies that give commitment in hydropower generation. One of the programs that being held by Malaysian government in 2009 is Sarawak Corridor of Renewable Energy, which is SCORE. This program is functioned to capitalize the 51 potential hydropower stations that the government had been identified which can give or provide around 20 gigawatts of capacity. Next, we also have Tenaga Nasional Berhad, which is TNB, the largest utility company in electricity. Government has targeted to increase the share of renewable energy to 31% in 2025 and 40% in 2035. Government Malaysia also target to achieve the environmental goal of reducing CO2 emission by 45% in 2030. Next and last subtopic in this presentation is about the comparison of hydropower generation in Southeast Asia. First, the largest hydropower station in Southeast Asia is Three Gorges Dam in China. This hydropower station generates around 22,500 megawatt compared to Malaysian largest hydropower station in Sarawak, which generates only 2,400 megawatt. Next, let's see hydropower station in Thailand, which is Bundang Prakanchan Dam. This hydropower station is the cooperation project of renewable energy between e-gate that use water from the dam with maximum benefit. This hydropower station installed horizontal shaft Francis turbine. The total capacity generated from this hydropower station is only around 78.7 megawatt. Last but not least, we have hydropower station in Vietnam. This hydropower station has 17.4 kilometer tunnel that been used to draw water from the river. This hydropower station generate around 2,200 megawatt capacity of electricity. From the research, by this construction, there are some difficulty during maintenance. I think that's all for me. Thank you. Let's proceed with other presenter.
Assalamualaikum and hi. My name is Nur Shahira binti Azhar and my metric number is 20109-2178. Here I will continue the next topic about discussion and conclusion. In my discussion, I will explain the detail on the advantages, disadvantages and any environmental issue related to the type of power generation, which is hydropower generation. First of all, I will discuss about the advantages. The first advantages of hydropower generation is it is renewable energy. As we know, hydropower generation is classified as renewable energy, which means it will never run out unless the water stop flowing. As a result, hydropower generation are built to last. The next advantage of hydropower generation is it is low emission because it does not create carbon dioxide, a greenhouse gas that contributes to global climate change. Hydropower generation also does not like the other non-renewable energy alternatives such as coal and natural gas. It does not release pollutants into the atmosphere after it is complete. The last advantages of hydropower generation is it is very reliable energy renewable source. Water flow is normally quite predictable, which is taken into account when deciding whether to build a hydropower generation. When energy demand is low, water can be diverted away from turbines, resulting in less energy being generated. The next discussion is about disadvantages of hydropower generation. Okay, the first disadvantage of hydropower generation is environmental consequence. When a dam is created, a previously dry land area is flooded with water. A non-natural water flow causes problem ranging from less reaching the rivers terminus to disrupting fish migratory patterns. Okay, the second disadvantages is it is expensive to build. Hydropower facilities can cost as much as $580 per kilowatt and typically range from 10 megawatt to 30 megawatt. The last disadvantages is hydropower generation is drought potential. If there is a drought and not enough water flows into the plant's ability to generate power might be significantly hampered. The good news is that most droughts are a brief interruption in the normal water cycle and should only cause a modest delay in the energy output. Okay, the last discussion I will discuss about any environmental issue related to the type of power generation, which is hydropower generation. Okay, the first environmental issue is water quality deterioration. The water released from a reservoir may have a different chemical composition than the water flowing into it. Next is dams on river. It can obstruct the river flows, affecting the habitat of a number of aquatic organisms. Moreover, it also can emit the greenhouse gases. At three different stages of a hydropower generation, greenhouse gas emission might occur. Emission from the manufacture and transportation of construction materials as well as work equipment occur during the construction process. Lastly, the environmental issue that related to the hydropower generation is destruction of biodiversity and ecosystems. Land clearing and removal of natural vegetation result in the loss of valuable vegetative community types as well as species and also habitats. The conclusion that I can make from this hydropower generation is one of the alternative for meeting the rising need for energy as well as dependable renewable resources. Affordable and dependable power is crucial to any nation's long-term economic prosperity and security. Implementing sustainable manufacturing is more important than ever for many different reasons. First and foremost, sustainable manufacturing is not only good for the environment, it also can dramatically improve the safety of the facility, employees, the goods and the community as a whole. By extending the efficiency of the equipment and process, it is possible to minimize energy consumption, production time, waste, and material use. Sustainable manufacturing enables clients to interact with the firm and builds the trust that you share similar values. Cleaner production, also known as pollution prevention, it is the continuous application of integrated preventive environment approach to process goods and service. Cleaner manufacturing may save operational costs, increase profitability and worker safety and minimize the business environmental effect. It also can help the comply with environmental protection regulations. That's all from me. Thank you.